Hey, it's Sue. Today we're going to talk about some review material on sequences and series. So this is from 10A. This is lesson 1.5, and we're just going to go through the pre-calc stuff here, which is a lot of it. All right, so we're going to talk about series of constants, which means we're using numbers. Okay, so don't worry about this part for now. So we'll start with sequences. A sequence is pretty straightforward. A sequence is just a list of things in order. They're usually numbers or something mathy, although they don't have to be. Everything is called a term. So, for example, this sequence has 1, 2, 3, 4, 5 terms in it, and the fourth term is x plus 1. In precalc, usually the first term is A1, which makes sense. Second term is A sub 2. These are subscripts. If you want to refer to an unknown term, it might be A sub I or A sub n. And we'll do this in calculus as well, with one difference. Sometimes our first term is going to be A sub 0, which seems odd to start counting at 0, but there's going to be reasons that helps us. And we'll see those later. Just don't worry about that now, but that's going to happen in the future. One of the questions that we need to talk about in calculus is whether sequences converge or diverge, right? And what it means for a sequence to converge means that the terms eventually get closer and closer and closer to a particular number L, which stands for the limit. So, for example, if you look at this example 1, these terms, here's my first term, my second term, my third term, my fourth term, my fifth term, they appear to be getting closer and closer and closer to a particular number. So we say as n goes towards infinity, as I have more and more terms, each term is getting closer to that limit. In this example, this sequence converges to 5. It gets closer and closer and closer to 5. We can say, look, they're getting closer to 5. If you wanted to pay a little more attention, we could write a formula for this sequence. Right? So let's do that. So my first term is 5 plus 3/10. My next term is 5 plus 3/100. My next term is 5 plus 3/1000, or 10 cubed. So you can see the denominators here are powers of 10. And if this is n equals 1, n equals 2, n equals 3, it might be clear that you can say that an is equal to 5 plus 3 over 10 to the n, where I start with n equals 1. The exponent matches the n. So in this case, if I'm asking about what's happening as n goes to infinity, I'm really taking a limit. All right? So as n goes towards infinity, 10 to the n also goes towards infinity, which means 3 over 10 to the n, this is 3 over a very large number, this goes to 0. And so that tells me, this is just my thinking, that tells me that 5 plus 3 over 10 to the n gets closer and closer to 5. The limit is 5. All right, and so we say that my sequence converges. Now, we've been a little sketchy on limits, and we'll continue to be informal with limits. If you wanted to be more formal, there's this whole thing called delta epsilon convergence, which I'm not going to get into. The idea is that if you want to say that something converges to L, we're saying that the terms get arbitrarily close to L. So when I say this converges to 5, somebody could say, yeah, but they get kind of close to 5, but do they ever get within 1/1,000,000th of 5? And I'd have to say, yeah, eventually these terms are going to get within 1/1,000,000th of 5, and I'd have to demonstrate how that happens. But that's really what these limits mean. It means you're getting as close as somebody else wants to 5. All right? But we're not really going to do limit proofs in this course, but that's the idea. So if a sequence does not converge to a finite number, we never converge to infinity. That's not a thing. Converging is only for finite numbers. If it doesn't converge to a finite number, we say it diverges. Those are the two choices. So what types of things diverge? There are some easy examples, right? So if you have a sequence like this, 3, 5, 7, 9, 11, are these terms getting closer and closer to a finite number? They are not. They're getting larger and larger and larger without bound. And so we say that this sequence would diverge. There are other ways of diverging. In this example, 1, -1, 1, -1, 1, -1, is this going to converge or diverge? So sometimes when I ask what number is this getting closer to, people say there are two numbers. No, 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 no. A limit has to be one number only. Sometimes people are like, well, we'll average them and say 0. I'm like, these numbers are not getting closer to 0. They're 1 away from 0. It don't get closer to 0, no. And this sort of thing diverges. So don't be tempted by those ridiculous answers. This diverges. It does not get closer and closer. It does not get closer and closer to a particular number. This diverges. One more example. How about this sequence? This is one of my favorite sequences. It actually has a name. It's called the Harmonic Sequence. Does this converge or diverge? Well, are these terms getting closer and closer and closer to one particular number? Yes. These numbers are getting closer and closer and closer to 0. So this converges to 0. That's sequences. So the next thing we'll do is talk about series.